So anyway, I'm Charlie Nielsen, the president of the club. Most of you probably already knew that. We're going to have some reports from some of the officers after the speaker, but as usual, we're going to have our speaker first. So if anybody really didn't want to participate in our lively and entertaining business meeting, we might let you escape. So with that, we're honored tonight to have Professor Gerdes, who is the chair of the physics department at the U of M. And I'll shout out to club member Debbie Smith, who asked David to come and speak to us. And we're pleased that she did that and pleased that David said yes. So David received his bachelor's in physics from Carleton College and his master of advanced study in mathematics from Cambridge University in England. After receiving his PhD in physics from the University of Chicago, he came here to the University of Michigan in the Department of Physics in 1992 as a research assistant, where he was part of an experimental team that discovered the top quark. He joined the physics faculty in 1998, and he also holds an appointment in the Department of Astronomy. A gifted educator, Professor Gerdes has received numerous University of Michigan teaching awards, including the Provost Teaching Innovation Prize, the Arthur F. Thurneau Professorship in 2007 for outstanding contributions to undergraduate education, the University Undergraduate Teaching Award, and the LS&A Excellence in Education Award, and there are many, many more. Professor Gerdes served as the Physics Department Associate Chair for Undergraduate Education from 2016 to 2019, and on January 1st, 2019, he became the chair of the Department of Physics. His career highlights include a career award from the National Science Foundation and an outstanding junior investigator award from the Department of Energy. He is a fellow of the American Physical Society. 6 graduate students have earned their PhDs under his supervision, and he has mentored dozens of undergraduate students in their research. David's group has discovered dozens of new trans-Neptunian minor planets, including a Michigan-sized dwarf planet nearly 100 times Earth's distance from the sun. Tonight, he's going to speak to us about stellar occultations and NASA's Lucy mission to Jupiter's Trojan asteroids, and we're honored to have him with us. So with that, Professor David Gerdes.
All right. Well, thank you for that very kind and generous introduction, and thanks to my mother for writing that. Well, it's a pleasure to be here, and thank you all for having me. So I'm going to talk with you about something that's not something that's I spend a great deal of my time on, but it's been a lot of fun, and I chose to talk about this particular topic of stellar occultations because it's actually science that amateur astronomers can do with normal-sized telescopes. You don't need a telescope in space. You don't need 4 meters of glass. This kind of science is readily accessible, and in fact benefits a lot from contributions of amateurs. And so I'm going to talk about how we sort of some of us at Michigan became kind of amateur astronomers for a week back in February to observe one occultation and what we learned from that. Now, actually, occultations have been in the news very recently. You may be aware that one of the brightest stars in the sky, Betelgeuse, was occulted by the asteroid Leona just this past Monday night. So I should just define what I mean by the word occultation for those who aren't familiar with it. It is when a body passes in front of a star and briefly eclipses its light. So you can think of an occultation as an eclipse of a star by an asteroid. And since most stars, in fact, Betelgeuse being a prominent exception, are effectively point sources. They have no, angular size to speak of. These are typically total eclipses. You'll see, of course, that in the case of the Betelgeuse occultation the other night, it was not a total eclipse of Betelgeuse. Betelgeuse is such a large star, and it's so close by that its angular size is, important. And it's comparable, in fact, to the angular size of the asteroid. And depending on the shape and rotational state of that asteroid, the eclipse of Betelgeuse, people had hopes it might actually disappear for 10 seconds, which would have been cool. That didn't happen. It dimmed by several magnitudes, and you can see that in this pair of images here, which was the astronomy picture of the day this morning. So thanks to that, a lot more people know what occultations are than might otherwise have. But I'd like to talk now about what we are learning about some of Jupiter's Trojan asteroids from the study of occultations that they produce. And I probably don't need to tell this group very much about distance scales in the solar system, but just so we're all on the same page, we like to measure distances in the solar system in units of astronomical units. It's a sort of standard ruler in the solar system. 1 AU is Earth's mean distance from the sun, about 150 million kilometers. And so we see there the 4 inner planets, the rocky terrestrial planets. And then if we go out a little further, we see the realm of the giant planets, the first of which is Jupiter. They're at about 5 AU, going on out to Neptune at 30 AU. And I actually spend most of my time studying what's beyond 30 AU out in the Kuiper belt. But we will go back in close now to Jupiter for the rest of this talk at about 5 AU and talk about what kinds of objects are out there. So we tend to think about the solar system in terms of the planets. And that's where most of the mass is. But most of the things in the solar system are actually minor planets, asteroids. And despite what you see in like sci-fi movies where asteroid fields look like these kind of random fields of boulders that you have to, bob and weave your spaceship through to not get blown up. First of all, they're not that close together. We send spacecraft through the solar system all the time, and they don't actually crash into anything. But also the asteroids have quite a lot of structure. And it's that structure that these dynamical classes of asteroids that are of real interest, because they, especially to sort of dynamical astronomers like me, because they really are an archaeological relic of the processes that gave rise to the solar system's present state. So for example, and so I've plotted here this semi-major axis. There's our ruler from 0 to 1 AU. So you see the 5 planets out to Jupiter. And on the vertical axis, I've plotted inclination. I'm sorry, I plotted eccentricity. So there's Mercury's orbit, Mars's orbit, and you see they're kind of not so circular. Then you see various families of asteroids. And so you see this band of asteroids that come near the Earth. You see inner main belt and several groups in the main belt, also some gaps. Those gaps correspond to gravitational resonances with Jupiter that are unstable. So anything that falls into that resonance gets kicked out. You see a band out here called the Gerdes that is a gravitational resonance with Jupiter that is actually long-term stable. So it's if you kind of think of the unstable resonances as bowls turned upside down, a marble placed on that bowl will roll off. These are bowls that are right side up, and a marble placed in that bowl kind of stays put. The Gerdes, when I say they're in a gravitational resonance, what I mean is their orbital periods are in a integer relationship with Jupiter's orbit. In particular, the Gerdes orbit the sun 3 times for every 2 orbits that Jupiter makes. That's a stable arrangement. In fact, it's sort of what protects them from ever getting close to Jupiter. And then there's this group out here, and although I'll show you on the next slide a 2-dimensional plot of kind of how they are arranged in space relative to Jupiter, this makes it look like they're kind of sitting on top of Jupiter, and they're not, but they are at Jupiter's same distance from the sun. And these are the Jupiter Trojans, and there's 2 groups of them. And they're shown here in green. So I'll let you kind of stare at this for a moment while I I talk. So the red dots are the Gerdes, and the green dots are the Trojans. And you see that the Trojans occupy two groups or two clouds, or actually what, because they're Trojans and we like Greek mythology, they're actually called two camps. So the Trojan, there's the Greek camp and the Trojan camp. And I always forget which one is which, but the ones that have names, you know, like have to be named after Trojans or Greek heroes, depending on the which they are. So those orbit in stable long-term configurations about Jupiter's leading and trailing Lagrange points L4 and L5. These are stable points in the Jupiter-Sun asteroid three-body system. And what I mean by that is, like, if you put an object at L4 or L5 and give it, you know, the right initial kick, it will stay there forever, for billions of years. That makes the Trojans really interesting because, as I said, they are, well, as I said in the title of my talk, they're fossils. They're archaeological remnants of this planetesimal disk that never got to be part of a bigger thing, you know, like a planet. And you also see there in red the Gerdes, that inner resonance, the inner 3 to 2 resonance. It's kind of an optical illusion. It looks like they're in some kind of triangular orbit. And they're actually going in ellipses, same as everything else. If you follow, I should have changed the color of one of those dots so you could follow one thing and convince yourself it's making an ellipse. But they do come to aphelion out near the Trojans, and in fact, it's sort of, they're a contaminant in our searches for Trojans because they tend to be very close to those Trojan clouds when they're at their furthest point from the sun. Okay, so the Trojans are interesting because they are believed to be pretty much unchanged dynamically since Jupiter got to its final position. But the interesting thing about that story is that Jupiter, as well as the other giant planets, did not form in their present locations. They actually formed closer to the sun than they are now. And then with this large planetesimal disk kind of outside of it, and then through a series of destabilizing events, eventually the giant planets migrated outward. In fact, the proto-Uranus and the proto-Neptune changed places. Neptune is thought to have been the third giant planet from the sun before the destabilization took place. Neptune migrated outward, plowing through this planetesimal disk, exchanging angular momentum and energy with it until it reached its stable location there at 30 AU. In the process, it scattered the remains of that planetesimal disk all over the place. A lot of it got ejected from the solar system, but some of it got thrown inward and captured gravitationally by Jupiter into the Trojan resonance. So the Trojans actually have a variety of origins, but it's believed that the dominant way that you got to be a Trojan was to be scattered inward from what's now the Kuiper Belt. So they're kind of inner solar system cousins of today's Kuiper Belt objects. In the 4 billion years or so since they arrived there, they have experienced a different environment. There's more solar radiation there. You know, it's warmer. They have probably evolved collisionally in a way that a lot of Kuiper Belt objects haven't. But you know, they are as pristine as you can be at 5 AU from the sun. Some of the Trojans were probably carried outward with Jupiter from places closer to the sun. So there's actually a diversity of Trojans, and that is reflected in their colors. So I've shown some plots of colors, and all you need to know about this plot is that each axis of each plot is a color, like red versus green. And you can see that these Trojans have a range of colors. They tend to be redder than solar. That's a sign of a surface that's been irradiated over time, and they tend to get they tend to get redder. We also, and actually this was a result from a paper that one of my undergraduates did and led, but we see a trend of, at least in some colors, of Trojans becoming a little bluer as they get smaller. And that could be an indication that the smaller Trojans are more likely to be collisional fragments of something and have younger surfaces that are therefore bluer and less aged. So this is all to say that the Trojans are very interesting, and they are in fact so interesting that NASA has approved a mission to go study the Trojans, and that's Lucy. Lucy got its name after the Lucy fossil that was discovered in Africa in 1968, 67. But the Lucy fossil got its name because the team that was out there at that site in North Africa, as I heard the story, they had kind of one 8-track tape, and it was Sgt. Pepper's Lonely Hearts Club Band that had come out that summer, and they played it over and over again, and they had Lucy in the Sky with Diamonds on the brain, but of course Lucy in the sky, and so around and around we go. You can actually find on YouTube a little tribute video that Ringo Starr made on the occasion of Lucy's launch, and he's like, Lucy's going back into the sky with diamonds, peace and love. So the launch was really beautiful, and there was this kind of low level of clouds, and it pierced the clouds in this gorgeous way. So it was launched on October 16th, 2021. It's led by the Southwest Research Institute, Goddard, and Lockheed Martin. So Lucy looks like this. It has these two large solar panels that unfurled kind of like a Chinese fan. It's the most distant spacecraft mission to make use of solar panels. So these are quite large solar panels, for missions like to other missions to Jupiter and beyond. Solar panels just don't produce enough electricity, so those spacecraft make use of a nuclear heat source. So there's Lucy. Much of the instrumentation on Lucy builds on the heritage of the New Horizons spacecraft, which, as you probably all know, visited Pluto in 2015. And actually, that's sort of my connection to this group of people, as I'm part of the New Horizons science team working with them on searches for Kuiper Belt objects. And cool story about my first day as chair. You mentioned I became chair on January 1st, 2019. That is also the day that New Horizons flew by a second Kuiper Belt object that was discovered after the Pluto flyby. The flyby took place at midnight on January 1st, 2019, and I was there at the flyby party, which was really cool. Of course, we didn't know until like 12 hours later that it had worked, but there was a special presentation that night by a New Horizons science collaborator and PhD astronomer named Brian May. Some of you might know him as the lead guitarist for Queen. So that was also pretty cool. He's got a PhD in astronomy. He went back and finished it after Queen, settled down. Okay, so Lucy is going to do a grand tour of a bunch of Trojan asteroids over the next roughly decade. Its orbit is so cool, I need to show it to you. And I'm going to show it to you. The view I'd like you to focus on is this panel on the right, which is looking down on the plane of the solar system from overhead, so to speak. But we're going to be looking in a frame that's co-rotating with Jupiter. This is Jupiter, and it's going to stay there. So it's as though we are kind of in a spaceship following Jupiter around the sun. So play this and try to narrate. So it was launched in October. After 1 year, there was an Earth gravity assist there. Earth is the green dot. Then a second Earth gravity assist that took place 2 years later. An encounter with the main belt asteroid there. Then it goes to the L4 Trojans, and it's going to hit 1, 2, 3, 4 of them late in this decade. Goes back into the inner solar system. A third Earth gravity assist that changes it out to L5, and there's an encounter with an L5 equal mass large binary object in 2033. It will stay on that kind of figure-8 orbit pretty much forever. You can integrate that orbit and see that it's stable for millions and millions of years. So there may be opportunities in the, after the last trip through L5 to, do something else with it. I think it's going to it's going to work for a long time. Unlike New Horizons, it's not leaving the solar system, which makes the problem of finding more targets for it a lot easier. So here's a summary of the visits and the dates of the flybys. So and actually this is out of date, and I'll explain what was added. But the flyby of that main belt asteroid, it's called Donald Johanson, who was the discoverer of the Lucy fossil, will take place in April 25. And then that's not considered as much a science target as a mission operations shakedown kind of a target. But then the real action starts in late 2027 and into 2028 when it's visiting a series of these L4 asteroids, including the asteroid Ptolemy, which is the one I'll focus on for the rest of the talk in September 2027. That third Earth gravity assist happens in December 2030, and then the flyby of the equal mass binary Patroclus and Menetius happens in March of 2033. This is an older slide, and it actually does not have a late addition to this target list, which was an inner main belt asteroid called Dinkinesh that was just added to the target list last February. Somebody realized that without going out of its way hardly at all, it could fly by this tiny little main belt asteroid, about 800 meters in diameter, that was subsequently named by the Lucy team Dinkinesh, which is the I forget what language, but it's the Ethiopian, I think, name for the Lucy fossil. And that flyby happened actually just on November 1st, and it yielded the first surprise of the Lucy mission. The surprise is that Dinkinesh is a binary. It's got a little moon. This 800-meter object has a 200-meter moon. And the second surprise of the Lucy mission is that the moon is a contact binary. It's actually two little 100-meter objects stuck together. Nobody saw that coming. Yeah, question.
Hey, let me ask, for closest approach, because I saw the last side relative is like 13 kilometers per second, 5 kilometers per second.
Yeah.
What is the closest approach you guys get to the
It is, I want to say, around 2,000 kilometers. It's not that close. And I think these were taken from a distance of more like 400 kilometers. It's through a small telescope. So that's pretty cool. Yeah. So there are a number of instruments on Lucy, and the one that kind of gives us the most readily digestible images to our eyes is the camera called LORRI, which is of the same heritage as the New Horizons camera that imaged Pluto. There's also an infrared camera. There's a spectrograph. I think there's a magnetometer of some sort. So there's a suite of remote sensing instruments. Oh, yeah. Yeah. So at 5 AU, there is 1/25 of the solar intensity that we have at Earth. So imagine a pretty cloudy day. That's how much sunlight there is at 5 AU. Here, there's more. I mean, even New Horizons in the Kuiper Belt there's enough light, right? No, this is a wealth of photons compared to the Kuiper Belt. So as I just said, that there was no real effort to study Dinkinesh before the flyby, like in great detail. Again, the Dinkinesh encounter was really intended as just a trial run, you know, of the choreographed sequence of events that has to take place on that spacecraft under its own autonomous control in the moments that the flyby takes place. And actually, one of those things that they were trying to test with this particular encounter and with the Donald Johanson encounter is the ability of the instrument to actually locate the asteroid and then adapt the pointings a little bit so that it's centered. New Horizons wasted a lot of bandwidth taking pictures of blank sky because they had to tile an area to make sure they got it. And Lucy has a way to do that adaptively on the fly. And it worked. But for the Lucy targets, it would be nice to know as much as possible in advance of the encounter so that they can, and I'm saying they and not we, because I'm not part of that science team, but so that they can plan the mission as knowledgeably as possible. Asteroids cannot be resolved as extended structures by even the most powerful telescopes on Earth or in space, with a couple of exceptions like Ceres. You can sort of see some stuff, but these little things you can't, they're point likes. The word asteroid means star-like, looks like a star. So how could you learn about its shape or whether it might have a satellite? The answer is through stellar occultations. And the basic geometry of an occultation is shown here. So there's some star, some distant star. And we really just think of these stars as a point-like source of parallel rays of light that an asteroid passes through and punches out an asteroid-shaped hole in those parallel rays of light. And that shadow of the star cast by the shadow of the asteroid, cast by the starlight, can cross the Earth, just like the path of the moon's shadow during a solar eclipse. And you can see it by watching that star disappear. So here's 5 hypothetical observers, A, B, C, and D. B, C, and D are in the path of the shadow. A and E are not. And so from the observer's point of view, here comes this moving shadow across the Earth. And during this little time window that it takes the shadow to pass through observer B, B will see the star disappear. Same with C and D. A and E don't see anything, but that's also important. It bounds the size of the asteroid. So these are called chords. And these 3 will get a chord and the other ones won't, but that's helpful too. So that's the idea. And so the Lucy team has organized an extensive campaign to put telescopes and observers in the path of these occultations for the Lucy targets. And this has been going on for the last couple of years. And the occultation of Ptolemaios, remember that's one of the L4 targets, on March 27th of last year, yielded a surprise. So in the upper left on this plot are the chords that were observed for Ptolemaios. So there had been a couple of earlier occultations that got somewhat fewer chords, but each time you observe an occultation, you get like a super precise measurement of the asteroid's position and its orbit. It's actually way better than like a Hubble measurement because you know exactly where it was at exactly what time. And that's so that lets you pack the track with telescopes really densely for subsequent occultation. So they had a plan, and they had all these telescopes in the path of the Palombali shadow for last March. And I wonder if I can get rid of that. And so they saw the star disappear for a fraction of a second. But then a couple of those ones that were actually outside the path, a few seconds later, saw the star disappear. Nobody expected that, but that meant that Palombali has a little satellite, just like Finkenich does. They called it Sean. If you're a fan of Wallace and Gromit, you know who Sean is. Sean is a brave little opinionated, independent-minded sheep. So this is 2 chords. This is really very little information, but it's super interesting because a binary is almost certainly a very primitive object that's been very much not disturbed since the beginning of time. It's very, very delicate. It's easily destabilized by passing objects, and so you see a lot of binaries in the classical Kuiper belt, not so much in the main belt. So although there's, of course, as we know, there's binaries in the main belt too. So we got to find out more about Sean. So the purpose of the occultation last February that a bunch of us from Michigan took part in was the Find Sean campaign. So the next Palombali occultation happened on last February 3rd, and it was ideally situated for a major campaign because, look, it's passing right through the heart of the US. In fact, it's passing not so far from Boulder, Colorado, which is the headquarters of the Lucy science team at Southwest Research Institute. They've literally got a warehouse with about 100 telescopes in boxes in it that they've been shipping all over the world for these things. But this was a question of recruiting. They wanted, Sean could have been anywhere in about a 100-kilometer, actually 200-kilometer path. With one observation like that, you have no idea what its orbit is. So we had to cover a much wider swath than we would have needed to do just to get Palombali itself. So the leadership of the occultation campaign, a guy named Mark Bowie and his colleagues. Mark has discovered a couple of the small moons of Pluto. He discovered Arrokoth, which was the New Horizons flyby target. He knows, all the tricks in small body solar system astronomy. He organized this occultation campaign and recruited about 100 teams of 2 observers each, rented about 70 large SUVs from the Denver airport, and recruited teams from all over the country. I brought 10 people from Michigan, and in February to try to catch this occultation. So here I'm zooming in, and each of these parallel lines is a track on which we wanted to put a telescope somewhere. Those are 1 kilometer apart, and I think the blue lines here are the primary Palombali track, but everything else was kind of this big picket fence to try to get Sean. So we spent a lot of time that week looking at the forecast to try to figure out, it's February, it's, it actually passed, if you look at this, it actually passed through our part of Michigan. I think the Palombali track itself passed through Lansing, but you all know the odds of clear skies on in February, but it was pretty good over the Great Plains. So we were fortunate. There's a guy who does forecasts for occultation cloud cover. He's got a site called OccuWeather, which I love. So my giant SUV with me and my partner on one telescope and then a couple of other observers on the second telescope, we got sent to this little area near McPherson, Kansas, and outside which is a suburb of Salina, which is sort of a suburb of Topeka, and then a little suburb of McPherson is another little tiny spot on the map called Galva. It's kind of like the Dinkinesh satellite of of McPherson. Galva is a tiny little town. It's sort of like Mayberry, and the people there were just wonderful. You have to imagine, like, you're in the middle of Kansas. It's the middle of winter, and a bunch of people show up in vans and start setting up telescopes. And, you never know what kinds of questions you might get asked. But people were absolutely great. And we go to the town hall in Galva and figured we should announce our presence and said, oh, we're astronomers and students, and we're going to observe this event from your town tonight. Oh, that's great. I'll tell our police officer. I'll call Stacy. and we'll talk to we want to be at the Mennonite church. Talk to Chad and Joe at the gas station. They belong to that congregation. They can help you out. Everybody was great. This was also, if you remember what was in the news early last February, this was also when that Chinese balloon was flying over. And so some people got asked, are you with the government observing the, nope, just a. Well, then, then if you say, but if you say things like, no, we're just here for an occultation, they think you're doing some kind of, black magic, evil. We're here to look for an eclipse of a star by an asteroid to help a NASA mission. That was what worked. Actually, very, very few people encountered any, difficulty. It was people were actually really kind of excited that something interesting was happening in their town. It's a real challenge. I mean, these are small telescopes, but you need to practice. And as you all know, you don't necessarily get it right the first time. So this team now has really quite a lot of experience in training observers to use this, to use their equipment, not equipment you bring yourself, to use their standard equipment to get it done. So we had an initial training session in some dance hall barn that they rented, how to set it up. Then we had a practice observing session in the parking lot of the warehouse. It was so cold that night. It was so cold. It was like 3 above 0 or something. And you have to take your gloves off to kind of operate the laptops and the telescope. It was so cold. I don't think I've ever been that cold. Stuff was freezing, like the threads were locking in the cold. But the goal was basically to be able to get on that star, in half an hour before the occultation. Just get on it, and make sure you can, stay there and track it, and then record data at 5 frames per second for the duration of the eclipse. Yeah. With a GPS. So the camera has a GPS unit attached to it. Timing is absolutely critical. You can't use like your PC time. You've got to. For the aficionados in the audience, the primary instrument was a Celestron CPC-11 with a Hyperstar prime focus adapter that goes on the front to make it an f2 setup, and then a fast CMOS camera. So we did, practice observing a couple of nights. Then the forecast was solid enough that we identified this region in Kansas that was about a 7 or 8 hour drive from Boulder, where we were convened. So we got there and drove and spent a night and did some practice observing there. And then finally it's the night. So there's my my teammate, Karina McCarthy, who was a student at CU Boulder. The moon was nearly full that night. Actually, another challenge was that this was a 13th magnitude star, and it was about 11 degrees from a full moon. But like this, an 11-inch telescope, like just this was all good. So here's what we saw. This was our data. There it goes. And it's back. Yeah, all that all that trouble. It's, and if you've ever seen like a solar eclipse, I mean, like you've got one chance to get it right. And that's why the practice was so important. So you put all that data together. So it so happened, this was this big 200-kilometer picket fence, and it so happened that my van was in the primary track of Polemele. So we actually saw something, and so did our other site. And so we were able to just, that night go back to our hotel room and quick reduce our data. And so these were two sites that were just a kilometer or so apart. One in the park in downtown Galva, one at the Mennonite church. And but you see, they saw different lengths of the cord. They've got different slices across Polemele. I don't know if there's anything to this sort of double dip in the blue one, or if that's just statistics of, the sky background. You see, it's sort of comparable to the zig and the zag of the noise in the when the star was not eclipsed. So I think it's just a statistic. Also, when we went to the town hall, and I was explaining our situation to the clerk, there was another woman there, and her ears pricked up, and she says, "Oh, I'm the newspaper reporter," and the newspaper reporter. Tell me more about. So I ended up doing an interview with her, and she got almost everything right. So, almost everything right. So you put all that data together, and that's what Polemele looked like from Kansas. So there were some good chords. Actually, there were some other observers. You might recall that shadow arced all the way across the Atlantic and then hit Spain. And there was a group of Spanish observers who saw it too, so that data got included. So that's exciting, but that was not the main purpose of this campaign. But there was also one detection of Sean, and that was critical. A second point on Sean is actually a lot of information. And from that information, and as well as the other occultation data from Polemele, it's possible to determine Polemele's shape and rotational state. It turns out that Polemele is kind of a hamburger patty shaped object with semi-axes of kind of circular in two directions, 13 and 12 kilometers more or less, but only 5 kilometers thick. So it's sort of a flat thing. And from this modeling, they've been able to infer Polemele's rotational pole, its rotation axis. Then, under the assumption that Sean's orbit has the same pole, which is a reasonable assumption, it should be kind of dynamically relaxed after all this time, then you can also, oh, yes, I put it here, work out that Sean is orbiting at a distance of 200 kilometers and has a period of roughly 15 days. It depends on the density of polemily, which we don't know, but we can take a guess. It's about the density of water. It's about 1 gram per cc. So that's a lot of information. And I think with probably one more occultation, it will be enough to reliably point Lucy at both polemily and Sean during that flyby. And what I think is so cool about that is that this was done with a team of 200 mostly amateurs. I mean, there were a handful of quote unquote professional astronomers like me, but I actually don't know how to operate an 11-inch telescope. Ask me about a 4-meter, but you know, I was probably behind the curve when it came to some of the real experienced amateurs who are, you know, who do this all the time. So, you know, a large team of amateurs was able to make a measurement that you couldn't make with a $10 billion James Webb telescope. You know, there is still a role for amateurs and for small scale telescopes when used in a coordinated way, in a time sensitive way, to do really cool science. So I thought I'd spend just a minute or two pointing out the fact that there's all these L4 targets and there's just the one at L5. The well, 2 if you count the 2 parts of the binary. But wouldn't it be kind of cool if we could find more targets at L5? And so I spent some time with a student over the summer looking into this. So here's a sky map, and that is the L5 Trojan cloud on the sky as seen by us. You see that they actually cover a wide area of sky. And for this little study, we considered, just to pick a day, what about an object that could be encountered on January 1st, 2033? Well, on January, I should say, this is the sky on January 1st, 2033, and that's where Lucy's going to be. So we used computers to make a bunch of synthetic Trojans that were at that location on January 1st, 2033. And you could ask the question, where are they now? Like, if we wanted to find them, where should we look? You might hope that there's just another little dot somewhere else and we should point at that dot. And unfortunately, that's not the case. So here they are. So here they are on January 4th in a couple of weeks, and they are pretty much as scattered on the sky as all the other Trojans. So thought that was bad news. But if you actually evolve them forward in time, something interesting happens. So watch this little movie. They're pretty spread out in 2024. But then they start to actually converge in this sort of bow tie shape in 2027 or so. And then they spread out again. And then as we approach the encounter date, they, you know, coalesce to to that point. But the interesting thing, you know, is that there's that sort of sweet spot in about 2027 where they're actually quite concentrated. The reason for that is that is half of an orbit period ahead of the encounter date. They have Jupiter's same orbital period of about 11 years. So it's about half an orbital period of in front of the encounter date. And so they're kind of converging at the opposite node. And then they spread out again in their inclined orbits. But the constraint that they are there on that date tells you a lot about where they are. So that suggests a strategy for finding them. There's that band, and of course it's a somewhat broader band if you consider other encounter dates in that general time frame in 2033. So that suggests a strategy, and we actually proposed for some time and got some time on the 4-meter telescope at Cerro Tololo this past August and September to try to do a kind of a prototype search. You know, it's not the right time to do it, but we could establish the technique and find some small Trojans. And all of our nights got clouded out. But it's okay. It wasn't the right time anyway, so we're going to propose it again to do next year. We think we can find Trojans down to about 800 meters in size, which is much smaller than any of the other Lucy targets. And of course, there's more small things than big things. And so I think our chances are okay. There are a lot of constraints imposed by the mission on what, there's only so much fuel you can divert it. The timing of the encounter with Patroclus is tightly constrained because they need to fly by it in a certain rotational state so that they can get good images of both components of the binary. But I feel like it's worth a try. So that's all I have to say about Jupiter Trojans and occultations. And for my last slide, I'm just going to point out that there is if you like the idea of stars disappearing because something passes in front of them, there's a really big occultation coming in April. And if you want to know a lot more about that, you can come to my Saturday morning physics talk. I see a few faces that are familiar from Saturday morning physics in this room, but I'll be giving a talk about this on February 17th at Saturday morning physics. So stay tuned for that. All right, thanks. Question?
Big telescopes that are out there, but I know they've got these survey telescopes now that survey the sky,
Right.
take all these images and such.
Right.
From that data, could you just look at it and look for occultations that are occurring?
The problem, so like the question is, you're probably thinking of some of the like the Mount Lemmon survey, Pan-STARRS. There's a whole observing program that is really focused on detecting near-Earth asteroids and potentially hazardous asteroids. The issue with those as occultation, kind of serendipitous occultation surveys, is that the occultations are extremely brief. The depth of that dip from Polemele was about a second. The depth of the dip from Sean was about a quarter of a second. So you're almost taking video, of these things. And typically, when you're using CMOS cameras that read out really quickly, like you have in your iPhone. The more standard large telescopes have CCD imagers, which have a slow readout, and they're taking longer exposures. And so if you take like typical 10, 20, 30-second exposures, you just miss it. I mean, if the star blinked out for a second out of your 20 seconds, you'll never know. That's the problem. Yeah, but it's a good idea. There are, the strategy of this, because we're trying to look for occultations of specific objects, is to move the telescopes to where the occultations are going to be. But you could imagine a different strategy where you just like build a little picket fence of telescopes somewhere and just point them somewhere on the sky where there's a lot of stars and wait for the occultations to come to you. And there's actually a project like that called TAOS. I forget, something Taiwan, something occultation survey that's doing just that.
On your chart of the eccentricity versus semi-major axis, what filter is Z? There was like, I think there was like an I minus Z.
Oh yeah, so Z is a very near infrared filter. Yeah, it's about micron.
Well, from the Zoom on.
Any questions from Zoom? There's something in the chat.
Charlie?
Oh, someone says, I have fond memories of heading all the way to a middle school lot with Jeff Thrush outside Fenton 30 plus years ago, using a PMT photometer and a C11 to measure an occultation of Vesta by an SAO star, becoming one of 7 data cords that revamped the size, shape, and orbital details that would later be verified by the arrival of the Dawn spacecraft. Were members of IOTA at the time, International Occultation Timing Association Fund Task. And I'm very grateful for that comment, because I meant to say that if you are interested in becoming part of this network of amateur occultation chasers, the organization you want to look into is IOTA, the International Occultation Timing Association. And I believe their website is occultations.org. And they maintain a list of occultation. Occultations themselves are not all that rare. There's probably 1 to 3 a night of some asteroid on some star that's visible from somewhere in the Earth. And, you know, you don't need a big telescope, right? A decent, even a, 6 or 8 inch telescope can get the brighter ones. Question there in the back.
Front of you is a table of common occultations
Mhm.
observers like us.
Mhm. Mhm.
Chart out all of next year.
Right. Right. Actually, the more important piece of equipment is a fast camera, so you can take this. We were shooting at 5 frames per second for this occultation, and GPS timing. That's critical. Yes.
So you mentioned.
Yeah.
You mentioned needing one more point of telemetry.
Mhm.
Do you have plans for that? Is that being talked about?
There's actually a preliminary occultation that's visible from Mexico in early February, and there will be a team going to observe that one.
Couldn't get on that.
I don't know that they're going to need us for that one. It won't be quite as big of a team. I'm actually going to Chile in February, so I might miss it.
Any other questions?
Actually, will there be,
Will there be any chances
for Lucy on the inbound to do some occultation
My last. Any chance of Lucy on the inbound to do what?
occultation
like for instance, to see help refine Sean's size and orbit?
For Lucy itself to what? To oh, I see what you're saying. Well, the stars aren't so different. Oh, I see what you're saying. I'm that's an interesting idea. Yeah, I think well, that's fine. I mean, that's GPS level precision anyway. I'm trying to think if the camera might not be fast enough. That's the same issue that I was raised with the it's a typical astronomical camera, so it's slow. The field of view is not that wide, but that's okay. It would be interesting to do a calculation of occultations that might be visible from Lucy itself. They would be very brief, given Lucy's speed.
Well,
Yeah.
Also, how much data did you guys use per telescope? Because I know the spacecraft can't exactly send a lot of data.
Right. So we got, of course, he wanted us to integrate for plus or minus 5 minutes on either side of the occultation, which was probably a little excessive. But I want to say from our telescope, that generated maybe few gigabytes of data. Times 100, that was a lot. But
So you could probably knock that down a lot, but that's still a good amount of megabytes.
yeah. So Lucy is closer, so its bandwidth through the deep space network is a little bit. It's much better than New Horizons. New Horizons is now at a kilobit per second. I mean, it's like your modem from 1978 that you would plug into the phone.
So I thought I heard someone from Zoom chatting in, someone.
Oh, chats.
Oh, yeah, here's what's talking. Yeah.
It's no advance.
Yeah, Charlie, I'm up here at Fish Lake. There's a little bit of background noise, but I was the one that put in the note about the Dawn mission and Vesta occultation. Back at the time, Jeff and I used a PMT photometer, and we didn't have much memory. We only had a limited amount of data space and streaming time to gather the data before we ran out of memory. So we had to know the timing of the occultation. So basically what I'm saying was a bit of luck involved. So we timed it just right, and we got lucky with the data cord. My understanding that Brian Autumn was going down to Miami this past Monday to get some data for the Betelgeuse occultation, but was clouded out.
Right, I think the only successful images I've seen of that one came from Turkey, from Europe. Yeah.
I know someone else who was going to get it down in the Florida Keys. And so if they got clouded out, then the only image you're gonna get is the one place on that line where it's sunny.
Yeah.
Yeah, if the line had gone through Michigan, I guarantee you there no Michigan would occur.
Question over here.
Not a question, just interesting comment. I was at JPL back in '83 and '84, and they were building LA. There was a talk on the advances in deep space communication from Echo to Galileo, where the figure of merit is bits per second per 1,000 kilometers. From Echo to Galileo was 16 orders of magnitude improvement. Wondering how much better it is now with a kilobit per second from New Horizons.
Right.
I don't know, how many more orders of magnitude?
I don't know.
Well, if you can imagine the Voyager spacecraft, how slow that trickles in.
Right. That's well under a kilobit per second, I think. It's not taking images though. It's really sending kind of telemetry mostly. Counts from radiation counters. Images are, pixels are costs.
Shut them off.
Yeah. Amazes me, is the data rate. It's, you got 90 watts going how far?
Right.
That signal is that.
Right. Well, it's 90 watts in a very narrow frequency range, which is, why there's enough power there to still see it. It's not, you couldn't see a 90-watt light bulb, but you can see 90 watts at this exact number of megahertz, right?
But even that's shifted because it's going with,
Yeah. So it's truly amazing. And the Pluto flyby data took over a year, I think, to fully downlink.
once per thing.
Right.
If I could add to his comment, and if my memory serves me right, which we'll see, Artemis 2, they should be testing optical downlink, so the lasers. Hopefully that'll get the data rate up for future missions.
They did. There was a successful test from forget which. Actually, was it for the space station? No, there was one that was
Is that Capstone or the one that?
true, and they were actually able to pull it to get the data. So it's optical, but I mean you have to aim so precisely. That's the problem. Optical, you really got to get
Right.
a very precise platform on the spacecraft to be able to hit them. I mean, you have the beam spreads, but then you have to be able to pick it up. But as you said, it's a very precise frequency. You know exactly what you're getting. But they have something there. It actually has to do with dynamic. I read an article on the feedback system that they were using for doing the focusing and beam. It had to anticipate because after all, you're traveling and everything's in motion. And they have a flight, and you have to work all of that stuff out. So it's not just aim at the Earth, it's much more complicated. But they actually did the test. I forget what data rate they had, but it was like a megabit. It's amazing. From 100, forget. I'm sorry, I'll try to see if I can find it and post something on the email chat. Chain.
Well, I feel like I'm delaying your discussion of the budget and the minutes and the minutes from your November meeting.
Assuming there's no another round of.
Thank you.
Thank you very much.
Token of our appreciation, we'd like to present with an official.
Oh, thank you so much. Yeah.
Looks good on it.
I don't think we need contact.
Well, yeah, we're showing the Zoom screen. How does our picture look on Zoom? I haven't.
Well, I can see those guys.
Where, oh, there we are.
Yeah.
Yep, I see this.
That looks good.
So,
Okay, I'm gonna end the Zoom. I think I launched this from my. Now, if you, do you want to keep the Zoom going for
Yes,
the,
keep it going on.
so maybe we need to make,
Well, it's on that one too.
yeah, but
Yeah.
I think if I end the meeting, I'm gonna just leave the meeting. And then I'm gonna assign,
Should be okay.
I just assigned this one as the host.
Okay, there you go.
So-
Yep, that'll do.
So I'm out of Zoom, but
Yeah.
yeah.
Okay. Yeah, just shut off this thing. We're okay there.
okay. For officer reports,
Excuse me, thank you very much.
Oh, you're welcome. Pleasure.
I don't have one, but I do have reports for 3 others. Yeah. And first is
Everything you measure is the asteroid
editor Amy,
Yeah,
who said,
shape.
yeah, it's.
You know,
Occultation is projecting a asteroid shaped
so Amy is
shadow onto the Earth of the asteroid that has the exact
She
size
does-
and shape of the asteroid.
for since the call for newsletters like
You know, putting your
comes
hand, you know,
with the due date of
shadow puppet.
and both dates
Put
are
your hand in a beam of light and there's this.
I'll send out the call on the 20th.
So that's what it is.
Mission deadline to January 2nd.
Okay, okay, good.
One text.
Oh, I think I still have my microphone on, which must be.
Yeah, there's two conversations.
Okay, now turn this off and if you want to use that.
Yep, thank you.
Since more info.
Okay. So next, Jeff Kopmanis sent us a report, and this one's a little longer. So he is saying that, oh, wait a minute. I got
Thanks,
that email, hang on.
Thank you.
Just find it, 1 second.
We will follow up.
Problem is, I got a bunch of emails to Jeff, and I gotta find the right one. Oh,
So Jeff sent it. Jeff sent
yeah,
it.
here, I got it. Yeah, I found it.
Okay.
Okay, he's got 2 items. One of them is just a reminder that the handbooks and calendars are here for the people that prepaid them. Some people didn't show up to pick them up. Some of you did get them. 2, he started the new observing sites page, and it is now online at the new club site under resources. We're interested in collecting info and images for members' favorite sites that may not be listed. If members have sites they'd like to add, I'd ask that they give us some description stuff. Just email Jeff at his email address, kopmanis@gmail.com, with a short summary description, what amenities it has, pros, what you like about it, cons, what you don't like about it, or stuff that's lacking, a website URL if they have one, an address or Google Maps location so we can include a map. The same list he is also going to publish in the December newsletter. And that was it from Jeff. And then I have one more from Brian Autumn. And Brian is saying that, as you know, we Lowbrow support astronomy at the beach every year. It is the largest public astronomy event in Michigan and drew over 3,000 last September. The new 501c3 nonprofit status means the event is in great shape financially. We Lowbrow support the event financially as well as bringing many telescopes. In addition, we have always had someone serve on the board. Going back a decade, we had Shannon and Joe, then Paul Wakalski, Brian Autumn, Jeff Kupmanis, John Wallbank, and Adrian Bradley. Now the board needs new helpers. Jeff will not be running for secretary again. Brian will not be running for communications marketing coordinator. So please let Brian know if you're interested or have any questions. That is it for Brian. And with that, I will go to the guy that's taking our meetings for us tonight. Thank you very much, Adrian.
So, let's see, I was gonna say nothing to report, but that's not quite true. So while I'm stepping down as VP, I talked to Charlie and a few of you for the meeting about looking at joining the communications subgroup with an interest in taking on the outreach, and now maybe you all can hear me. So while stepping down from VP, I still had an interest in joining the communications or staying a part of the communications committee with looking towards taking on the outreach portion, where most of the time we get outreach messages. I bet you this is a call. No, it's not. We get outreach requests from libraries, from other organizations, some of us, schools, things like that. I considered being a focal point for that. In other words, taking the requests, scheduling them, and then finding out if there will be lowbrows to cover. And if there will be lowbrows, I can let whoever the entity is know. If we don't have any lowbrows that can do it, I'd be the one to tell them that we're not able to staff, whatever said event. So kind of being an outreach coordinator through the communications group. So that is something I'm interested in doing, and basically helping. I know our outreach numbers, for those who, if we can talk about the survey a little, those outreach numbers were very low. That would be my contribution to the club for helping to make sure we don't lose our outreach focus altogether. So something I'm considering doing. And that's all I got.
That'd be well. Oh, did you want to make a motion on that?
Yeah, and I'll make a motion that I'll start by saying, let's make a motion to donate an amount to the Vatican Observatory Foundation. What that amount is can go in another motion, but if we vote as a club to donate, then that's the first step. So I'd like to move that we donate to the Vatican Observatory Foundation.
What sprung this is the last time, which was a year ago, January, next month. Brother Guy did his latest presentation for us. He's really become a regular speaker. And thing is, Brother Guy really can't accept gifts, so I can't give him a t-shirt or anything like this. And anything you do give him has to go into a pile at the end of the year, and they can't keep it. So we came up with the idea of donating to the Vatican Observatory Foundation, which we could do. And what did we give him? A couple $100, I think.
That I don't remember. Doug, you're on the screen. Do you recall what we may have donated last time to?
I'm trying to look it up in my records here. I'm pretty sure it was hold on. It's the top line in the spreadsheet. Yeah, it was $200.
Okay.
It was $200 when we made that donation on the 6th of April of this year.
Okay,
That's right. It took us a while to figure out how to actually do it.
Yeah.
Well,
Yeah.
to see how it flies, I'd like to support that motion and amend it to offer the amount of $100. What do people think of that?
So when would we want to do that? Would we want to do that now? Do we want to make that an annual thing? Like automatically, I think every year I do 250, I think, to Dark Skies, formerly International Dark Sky, whatever.
Yeah, true. I'd be in favor of doing $100 annual.
Yeah, I'd second that. That's,
Well, I mean, again, brother guy's been a regular speaker and probably will continue to be.
with the caveat that if, I know the treasury's fairly healthy, but with the caveat that if the treasury begins to fall, that we would revisit that, in terms of what we would do on an annual basis.
Yeah, I don't see that happening anytime soon. I could just put it in my annual schedule, come April, send $100.
Yeah, that sounds good to me. I second the motion of 100.
All right, so we have a motion to donate to the Vatican Observatory $100 on an annual basis. All in favor?
Aye.
Is anybody opposed? Motion carries unanimously.
We also send a hat.
For the photo opportunity.
Yeah.
Charlie,
Okay.
may I ask a question?
Yes.
Since you're at the Detroit Observatory, are you paying a fee to utilize that space? I'm summoned for donations to the Detroit Observatory every year, and I gladly give money to support it. Is the club supporting the Detroit Observatory at all?
I won't say no.
I know. Austin's got a smile on his face. No, we are not doing that.
No.
Well, tell Austin I am sending some money in here soon, so.
Okay. I'll start some officer conversation about that. I come up with.
We would be very appreciative.
Cool. Yeah. All right.
That goes in our annual donation as well, but.
Yeah.
Right.
That'll make a good January meeting topic.
Yeah.
I'll write that down, Detroit Observatory, and that's all.
Yeah. We'll capture in the minutes and maybe we won't forget.
Yeah, Detroit
Or
Observatory.
as easily forget. Okay, with that, Dave?
Okay, so with the survey, we've been. So with the survey, we've been talking a little bit about having club members get more involved. So there's a number of possibilities. The first one is with Adrian stepping down as VP, there'll be an opening for VP. Now, the elections are in April, but it might not be a bad idea for people to think about it if somebody might want to become a vice president. We have a couple committees, the Observatory Committee and the Communication Committee that Adrian mentioned. If people are interested in those, the Observatory Committee is mainly works on maintaining the 24-inch telescope in each mountain. Communication Committee, in addition to what Adrian said, I mean, we've also been talking about the new website and social media and that kind of stuff. So those are possibilities. There are other things. I mean, it seems like amateur photography is something a lot of people are interested in. We could start something up with that. So if they're interested in, doing some of these things, or starting up a different kind of special interest group, let me know.
Yeah. That's it.
Thank you, Dave. And that is all the officers we have in the room, but in the audience, we have our treasurer, Doug. Yeah.
Well, hello there. Not a lot to report. We're down to under 200 members. We're at 197 now. Memberships, actual people, it's more than that. The only big expense we did was, Jack installed some new fans on the McMath, and the total cost for everything involved there was $206.62. And I don't know, what about the dehumidifier or something, or is that something different? Am I mixing that up? I might be mixing that up.
It's space heater.
Yeah, the space heater. Was that I don't know if I've got the bill for that. Anyway, I'll have to look that up. So I might be missing something. The other thing is, Jeff Kopmanis is in possession of all the RESC calendars and handbooks, and he's in the process of getting those out to people. So it'd be really nice for him if people that ordered and they pick them up or arrange to pick them up in a timely manner. We still have 7 calendars available to order, and we still have. Oh, not anymore?
Yeah, Adrian's got one, and maybe that was it. And 2 of the handbooks are gone. Austin and Ken.
So we have
Okay.
6 calendars and.
I don't have payments for those, so.
No, they're gonna contact you about that. I think they're gonna go pay
Oh.
that.
Yeah, I'm gonna
All
make
right.
it now for you.
So we have 1 handbook and 6 calendars.
Okay. Okay, good. The other thing is with the holidays coming, if you're looking for a gift for your loved ones or other friends or just people on the street, we have a lot of t-shirts, we have a lot of sweatshirts, long sleeve tees, short sleeve tees, caps. We have a lot of caps. By the way, Charlie, that cap that you handed our speaker, was that one of those low profile ones?
No, that was the high profile, regular type one and the small medium size.
It was the small medium. Okay.
Yeah.
All right. So if you're interested in ordering any of that, I got a whole bunch of that stuff here. We replenished our stocks here earlier this year, so I have a whole lot, and just contact me. Anyone at the meeting now, anyone listening on Zoom, anyone watching this online later, let me know. So that is my report.
Okay, thank you, Doug. How about Jim? Jim?
Oh, you're talking to me.
Yeah.
Not a lot to report. As the officers certainly know, and probably a number of the members, I'm pretty concerned about members taking more responsibility for club activities. And that was one of the things we saw in the survey, not many people checking off. The recent issue of the Astronomical League's newsletter Reflector has some ideas that came out of a survey done by Astronomical Society of the Pacific and Learning Innovations funded by the National Science Foundation. And they came up with some ideas that are pretty solid and some a bit startling, like term limits for the officers, making, I guess that would force people to take an interest in the club if they really wanted to have one, because folks like Doug and I and Charlie and a lot of the other officers have been officers for a decade or more, and in the long run, that's not healthy for the club. And so we have to figure a way to bring more people into leadership. It just can't be the same old folks, no matter how much we enjoy doing the jobs or how well we do them. We're not going to be around forever for one reason or another, and we need new people. Adrian's had to dial back, and so we've got a slot open. And I guess we'll be discussing among the officers, some of these ideas and what we feel is viable, what might require a bylaws change and but I think we do need to move ahead and get more folks involved in running the club.
I will add to that, Jim, as the outgoing, hanging it up. If you are in this meeting, you are very much qualified to consider taking on some of the roles. I know the Hillocks have done it in the past. You all are just here to make sure the club doesn't completely die. And, you know, and Charlie's been the president since, I don't know, 1956.
Too far back to remember.
Yeah, yeah, since before space flight. So there are opportunities, and those of you here have enough interest in the club and didn't leave during our business meeting. Don't worry, qualifications, that means you're qualified because you're interested. You two over there running the observatory, you can all join us.
You're not safe.
So keep that in mind. I will say, I know part of the Warren Astronomical Society, they do use term limits. What ends up happening is the same officers then shuffle positions and start a new term in a different role. So that can happen, but
I know years ago, we did have a little discussion about term limits.
Yeah.
Quite a while ago.
No, it's Milton.
Yeah, Milton brought that up, and I
yeah,
think the
so
reason we kind of back up, we have such trouble finding officers as it is, do we want to force it on us?
Yeah, I think there are a number of ways of working term limits. You just don't simply say 2 years and you're gone. There could be a period where you can't be an officer. That could also be part of the deal. I think the state of Virginia, it's one term and your governorship is over, but the subsequent election to that, after you've been off for 4 years, you can run for governor again. So it's not like we're saying people are toast forever if we have term limits. That, like the state legislature does in Michigan, or the governorship in Michigan. Those, there are different ways to work this. So it doesn't have to be a forever thing, but we do need people that are familiar with the club and its inner workings and are willing to put in a little time. Because for most of us, it doesn't take a lot. And there are ideas in this study about how to bring people along so that they feel comfortable taking these roles.
That it, Jim?
That's it.
Okay, thank you much. Anybody have anything else? Zoom audience or in person?
where would a new
Dimitri?
member to the Lowbrows get started if they were interested in taking a more active? We should read the rest of that comment.
Yeah.
Activities.
That's a new toy.
Charlie,
Go ahead.
Charlie?
Yeah.
Yeah, I'm up at Fish Lake. You can see I purchased a used Sea Star, so I'm anxious to try it. But last night we did get it to run, and the results on M31 and M33 in the dark skies up here was, it convinced me to spend a few more bucks. Like I need another telescope, right, Doug? But anyways, and we did have the other scope out too. It was pretty, and I just had to comment that the Geminids were just again phenomenal last night. The fireballs and the NASA, I guess, according to Space Weather, recorded 176 fireballs over North America last night. And we were all impressed. Joe Brousseau, Kevin Daney, Jack Underwood, myself, a few other folks are up here, and the Geminids impressed this year. So, and the prediction for the peak was the previous night, and I saw hardly anything. And last night we were figuring, we'll see one or two. We saw probably a couple hundred meters. It was gorgeous.
I think I think the prediction was off and you saw the peak. It was off by 24 hours. Two, I want to really quickly address that question. Where would a new member get interested? Talk to one of the officers. You know, it's easier if you're in person because we can talk to you directly. But you can send that email. Where do I get started? Send it to the general membership and officers can get a hold of you.
Yeah.
Well, we definitely will.
Yes.
We always need help at open houses. That's an excellent way to get involved. And where we need you the most, really, most of the time.
And Nora, there's gonna be another attempt at the kind of a star party at Fish Lake. Like the one that you told us about either early this year or last year.
Yeah, Kevin Daney is sort of heading that up again. It's in May. We'll finalize a date in May and have folks notified after that.
Okay.
Yeah, I do have one other thing, Charlie.
Yep.
Our open house schedule for next year. No one is prepared to talk about it tonight, but in January, I think we have to finalize it.
Right. Dimitri?
I want to throw the idea out there because I threw it out, I think, last March, probably wrong, but around early this year. And I threw the idea out earlier this year and I just want to bring it back up. We were talking about public outreach and I don't think there's any better form, and correct me if I'm wrong, of public outreach than just good old sidewalk astronomy. And you get here, for example, you could do it here during some event or not even during some event, just find a high traffic area, get a couple of us out there with our scopes. And I'd be more than happy to volunteer for it when I'm up here. And I can't think of a better way to do public outreach and get people interested.
When is the art fair?
Yeah.
Third week of July.
Yeah, Thursday to Saturday.
Yeah, because and then all as well, because I did it. Someone trying to say something? Okay, because you don't necessarily need an event either. I was doing some sidewalk astronomy at my university, and universities are probably a better place to do it because everyone's kind of not on a strict schedule, but just like you guys know, grab people off the side. Hey, do you want to see Jupiter? Usually that gets people interested. Doesn't necessarily have to be an event, but yeah, that's all I have to say.
I noted that in the minutes. That's it's a great idea. The execution of which actually can start with one person.
The execution of that could start with one person or two. So we would just have to, we do have to balance it with the events that we have on a calendar, as well as events that we may be asked to do by other organizations that are looking for astronomy clubs. Whenever something big is in the media, chances are libraries and other, we'll be looking for astronomy clubs to explain it. And so there would have to be a balance, but very good idea. Basically have to be willing to trot your scope out. Even just looking at the moon, with the moon coming back, that might be a pretty good start.
Would we be able to get access? I don't know what it is with UNISH, but I know they probably have like outdoor outlets. Would we be able to get access to those? I just assumed like most for like outdoor electricity, most like street lights, or not most, but a good amount of them, they'll have like power outlets on them. Like, are we able to get those turned on? Like, would we be able to say?
Need the electricity.
Yeah.
That's true.
With batteries, power scope, we wouldn't need the electricity.
Okay.
You could go into the yard and do something if you wanted to. Of course, people would have to see. So if you go on the sidewalk next to the yard, just have to think of some places where you're out of the way, yet, you know, if a line does form, it's not disrupting something else going on around that area.
I think a successful place was on First Street. We used to do stuff there, right in downtown.
Okay.
Ashley. Or was it
Ashley
Ashland? That's what I'm
Street.
thinking of. Yes, it was on Ashland. Yeah, yeah.
Yeah,
Yeah.
and it all depends on, as I see my buddy Jim here, it depends on the health of the people that are able to get out there, which is a unique situation with our club, is that we are attempting to regenerate ourselves. You know, myself included, I'm one of the younger members of the club, so you know, it is on us to take on some of that, you know, doing some of the work. Patriots, you know, and you're probably the youngest person here. Probably, I don't, we have a gentleman over here. But yeah, all of these ideas are great to discuss. I won't hold us up anymore, but those are things we could continue discussing outside of the meeting, sending emails. I guess we should be careful, Doug, I know you're listening, Scoble, maybe be a little more careful about the number of emails we send so that we're not flooding email. But you know, we try and use it, you know, informational without overdoing it. And I think we're gonna need to really fire up the astrophotography group and make sure everyone who's sending all these great pictures, we go back to just using that. That'll clear a lot of the traffic. You know, there have been great photos and we want to see those, but we want to make sure that we, you know, we're in a forum where, you know, people are asking to see those photos. If you join the astrophotography group, AAPP, I think, Lowbrow AP or something, you'll see astrophotography groups.
Yes.
So on the new website in the members only section, I started a page, special interest groups. So I can add those, you know, so it'll be, add something like amateurs of photography, and then information on how to join. So
it would be nice to have like just a button or something you could click on the website to say, hey, I want to join this group, to make it easier. Because right now, typically they'll ask me, and then I have to ask Jeff, or I have to ask somebody, and then they have to add them to the group. And you know, it's kind of be nice if it was just easy. Go into the website, click this button. I want to join astrophotography. I want to join ACNO. I want to be removed from something. You know, it's like, the easier we can make it, the better.
yeah, that was the idea on that. So we'll.
Yeah, and that, I think we'll end up fleshing that out as we go. But those are some good ideas. I tried to jot them down here in the corner of the paper so that I wouldn't forget. And that's something that, you know, definitely we go to Jeff, the communication committee, to discuss. So yeah. That's all I've got. And Jim, anything else? This was on your report.
Oh, I'm fine.
Okay.
So Adrian, are you taking the minutes?
Yeah.
Okay. I'll do my usual
Send the email
report to make it easier for you.
Thank you.
And I'll send you those emails if you didn't get them from Amy and Jeff.
Sure. Please do.
And who else?
I don't mind having a couple
Oh,
pounds.
and Brian.
Yep. And I wrote down in my notes that there were emails.
Okay.
For it. And then the rest of mine, Dave, Jim. I have notes from Norb about the Geminids. Norb, I put you in the minutes. Sort of astronomy interest, all the Geminids you saw 24 hours after the predicted maximum. And Dimitri, I put in your note about sidewalk astronomy. I thought that'd be good to have in the minutes. And then your note on the website and the basically an astrophotography group. Because I think a lot of us are interested in astrophotography. I know you are, and you might be. And the Helix have been doing astrophotography for years and years.
they've bowed out now, but, yeah, so we're gonna try and we'll embrace the beginnings of that, and, it's a gradual thing, right? But we know a lot of folks love great space pictures. And it's a little bit of a departure from, you're looking at a gentleman on the screen who's got a 16-inch dial. I took a view through that and saw a lot of detail on M82 that, I've only been able to see similar stuff through long exposure photos. So, we want to preserve the visual side of our hobby while embracing the fact that a lot more people want to take these pictures. Sea stars are big because they help you do it. EV scopes, same sort of thing. And with that, I'm gonna go on mute, Charlie, or else we'll be here till 10.
All right. Does anybody have anything else?
Motion to adjourn.
Okay, we have a motion to adjourn. Support. Is anybody opposed?
Okay.
Thank you, everybody. And
Good night,
happy
everyone.
holidays. We'll see you next year.
Yeah, next year. All right, see ya.
There you go.
Thank you, sir.
I didn't. So, the observatory.